Welcome to The Explainer. I am absolutely thrilled you're joining me today because we are looking at something that has the power to completely revolutionize how you tackle your exams. Today, we're diving deep into the Cambridge Physics syllabus. We're focusing heavily on 0625, but listen, if you're taking 0651, 0652, 5054, or even 9702, this is absolutely crucial for you too. We are going to transform you from someone who just memorizes facts into a strategic exam grandmaster. To set the stage, I want you to imagine a real Cambridge Physics past paper question right in front of you. Think about two typical students taking this exam. Let's call them Alex and Sam. Now, Alex is the kind of student who overloads every answer with raw physics facts but completely lacks analysis. Alex just brain dumps every equation they can remember. Then there's Sam. Sam rushes. Sam is racing against the clock and completely misses the command word requirements. They both get the question wrong, and their papers are covered in red pen marks. Our mission today is to make sure you do not make Alex and Sam's mistakes. We are going to think 5 moves ahead and anticipate the examiner's next mental move using first principles thinking, specifically looking at volume and density.
Here's our strategy map for this session. We'll be moving through the Volume Density Challenge, our 4-step master strategy, cause and effect physics, escaping exam traps, real-world applications, and finally, a quick recall system. Let's get right into it.
Section 1. The Volume Density Challenge. Making the concept necessary, not decorative.
Okay, I want you to really think about this starter question. What physical effect actually depends on volume and density? This is where our friend Alex goes wrong. When faced with this, Alex will just spit out a memorized definition. But the best way to avoid depending on memorized wording is to figure out why a concept is actually necessary in the physical world. When you approach learning this way, concepts become vital tools rather than abstract chores. And this is exactly how you decode those tricky Cambridge assessment objectives. You see, the examiner isn't just testing if you read the textbook. They are testing if you understand the core mechanics of the universe. This vastly improves your capability to reason through completely unfamiliar exam questions without panicking. This is where concept-first learning becomes your absolute secret weapon. And it's the foundation of what I like to call the PEAL framework. PEAL stands for Point, Evidence, Explanation, Link. Before getting bogged down in the complex jargon of Cambridge Physics, you make your point using everyday language. You establish the core idea, like packing clothes tightly into a suitcase to understand mass compacted in a space. Once that everyday understanding is solid, then you layer on the formal scientific vocabulary for your evidence and explanation and link it back to the question. This is how top students structure their answers. Now, before we continue on to the next section and look at exactly how to implement this, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 2. The 4-step master strategy, the micro gateway to scientific patterns.
To unlock the examiner's mind, you must walk through these 4 linked steps, which perfectly align with our PEAL framework and help you decode command words. First, identify the exact quantity or phenomenon. Say, density. That's your point. Second, state the relationship involved, mass per unit volume. Third, explain the underlying physics of why it matters, like how tightly atoms are packed together. That's your evidence and explanation. And fourth, connect it to a real observation, like why oil floats on water but a penny sinks. That's your link. This sequence is absolute gold, because the best exam answers demonstrate both pure theory and practical application. If Sam, our rushing student, had used this 4-step strategy, they wouldn't have missed the command word requirements.
Section 3. Cause and effect physics, building logical chains.
We are now entering the transformation phase of our explainer. Imagine those red pen marks on Alex and Sam's papers physically transforming into green check marks. There is a massive difference between a student who just memorizes isolated facts and an exam grandmaster. A grandmaster insists on finding the physical cause and effect. Whether your topic involves fields, forces, or volume and density, you have to refuse to memorize isolated facts like Alex does. Instead, you build unbreakable cause and effect chains. Let's rewrite an answer live in our heads using the physics success blueprint. You don't just write that heating a gas causes it to expand. You write that adding thermal energy increases particle kinetic energy, therefore the particles collide with more force and spread out. Therefore volume increases, and because mass stays the exact same, the density decreases. Boom, full marks. Stop scrolling, subscribe to our YouTube channel Ace the Exams, at AceTheExams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries.
Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's look at this brilliant quote from our source material. Use one symbolic relationship or definition only when the class is ready for it. What does this mean for you as an exam candidate? It means you shouldn't just jump straight to the equation. It's incredibly tempting to just memorize the formula for density. Density equals mass over volume and think you're done. But if you don't understand the physical reality of mass packed into a specific space, that formula is just a collection of useless symbols. You have to build the conceptual chain first.
Okay, welcome to our interactive workshop. This physical understanding applies directly to visual data too. Challenge number 1, data scan. Imagine a complex mass-volume graph right in front of you. I'm giving you a 60-second mental timer right now. Whenever you see a graph, you must extract the core trend by looking at 4 specific keys: slope, area, direction, and shape. Don't just look at the line and say, it's going up. That's an Alex answer. Ask yourself, what does the slope actually represent in the physical world? In a mass-volume graph, the slope is the density. Connecting visual geometry back to physical cause and effect is exactly how you ace those intimidating structured data questions.
Section 4. Escaping the exam trap. Anticipating the examiner's mental moves. If you want to guarantee your marks, let me introduce you to the DREA method. DREA. Think of this as the ultimate defensive sequence, specifically tailored for physics, working hand in hand with the Peel framework. It stands for definition, relationship, explanation, and application. This structure keeps your answers tightly connected to actual physics. You define the terms, you state how they relate, you explain the physics behind that relationship, and you apply it to the scenario. Follow the DREA method, and it becomes incredibly difficult for a Cambridge examiner to deduct even a single point from your paper.
Interactive challenge number 2, find the flaw. I want you to imagine a flawed sample paragraph written by Sam. Sam writes the formula for density, says objects sink, and gives an example of an anchor. Where are the lost marks? Here are the 3 most common exam weaknesses. First, writing correct formulas without explaining the variables. The examiner needs to know that you know what M and V actually stand for. Second, quoting a process without linking it to a physical effect. And third, giving an example without showing why it follows from the physics. By using the DREA method, you brilliantly sidestep all 3 of these traps.
Section 5. Real-world physics applications. Outside the classroom.
Ideas from volume and density do not just sit in a Cambridge textbook. They literally form the foundation of our modern world. And examiners absolutely love testing this. Look at this list: engineering and safety, transport and energy systems, communications, medical technology, astronomy. For instance, the density of a neutron star is so unimaginably high that a single teaspoon of its material would weigh billions of tons here on Earth. Now for interactive challenge number 3, speed writing. You have a 30-second mental timer. You should always be able to pull from this list and name at least one real-life arena where understanding volume and density is critical. Having a real-world anchor gives you perfect ammunition for constructing a Peel paragraph for those high-mark real-world context questions. But here is the absolute most critical distinction. It's not enough to just name-drop medical technology or astronomy. You must justify the link clearly. Explain exactly why the physics drives the outcome in that field. Why does understanding the density of a material help an engineer design a safer steel ship that won't capsize? Because the overall average density of the ship, including the hollow volume of air inside it, is less than the density of seawater. How does predicting volume changes in gases allow us to improve energy systems or transport, like a hot air balloon? You have to show the direct, logical link between the classroom principle and the real-world outcome.
Section 6. The quick recall system. Securing the topic.
We are entering the final system. When you're revising, passive reading is your absolute worst enemy. You need to actively test yourself to ensure you've hit 100% mark potential. Here are the 3 overarching rules that guarantee top marks. Number 1, command word decoding. Don't be like Sam, answer exactly what is asked. Number 2, Peel framework application. Structure your DREA points logically. And number 3, a time management matrix. To study quickly, use these 4 specific prompts. 1, what is the core idea? 2, what changes physically? 3, what exact quantity or graph shows this change? And 4, where is it practically used? These steps force your brain to synthesize the definition, the physics, the data, and the application all at once.
So as we wrap up, I'm leaving you with a final challenge. Can you answer those 4 recall prompts aloud right now without looking back at your notes? Try to articulate the core idea of volume and density, what changes physically, how we graph it, and a real-world application. Listen, students who implement these physics strategies see an average improvement of 2 full grade boundaries. But that only happens if they practice consistently with our weekly sessions. So here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Also, drop a comment below with your target grade for physics and the biggest challenge you're currently facing. Our team responds to every single comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. See you next time, Grandmasters.